Hello, I'm Philip Muggleston, and in this series of videos we're covering the predictive capabilities native to SAP HANA. In this video we're going to look at weighted score table. Now, this is very useful for credit scoring, for example whether or not you want to approve a loan or mortgage for a prospect or customer, or to identify a group of customers that you want to target with a very specialized and personalized offer. So effectively, scoring is about assigning a single number that best represents a customer or whatever entity you're dealing with. So for example, if we were to have some customers, we would have different bits of information, different variables on each customer. For example, we may have the age and we might have the amount that they've spent in our stores. So the age, for example, should be from maybe 20 to 29, already grouped, 30 to 39, 40 to 49, for example. And the spend, for example, they may have spent 100 euros or maybe 1,000 euros or 10,000 euros. So you've got values, you've got for every customer, basically you know their age, their spend, and you may have 10, 20 or more of these different variables for your customer. So the weighted scoring basically is a way to transform this information with some information about how important the relevant things such as age or spend may be to get an overall combined score for that customer. So the first thing we want to do is say, well, how important is age? Maybe we'll rank age, we'll give that a weighting of say 2, whereas spend will give a rating of 3. Spend is more important than age. We could have a large number here with a lot of different weightings. And then for each value of age, because we've got age and spend, for each value of age, we could assign a weighting effectively for that value. For example, if we're more interested in older customers, we might give a weighting of 1, 2, and 3 based on how old they are. But if we want to identify maybe those older customers that are not spending much, we might give much more importance, for example, to customers that are spending smaller amounts of money as against ones that are spending higher amounts of money. But that's completely up to you to decide those weightings, both for the variable itself and also for each value of that variable. Now there are two types of variable you can have. It can be either discrete or continuous. So in this case, discrete one with age, we've already binned it or we've grouped it into some nice discrete groups. It could be maybe gender as being male and female would be another good example. Spend, however, the number could be anything. It could be from 1 to 200 million. So for that case, what we would probably want to do is actually do some binning in this process so that we can assign an individual score to a range. So that's something that we'll be able to do when we're working with the predictive analysis library. All we now need to do to actually work at our score, for example, for a customer, if we have a customer and customer 1 is 28 years old and he spent 200 euros, then we can work out his score. What we would need to do is first look up which age group. Okay, he's in the group 20 to 29, so we give him a score of 1 for age. We then multiply that by the weighting for age itself, which will give us a score of 2 for age. Then we will do the same for spend. So 200, he would be actually probably in this case, whereas we've given the ranges here, he's between 100 and 1,000. So that would be 3 for spend. And then we would then multiply that by the ratio or the weight we've applied, which is 3, which will give us 9. And if we then sum that together, the overall score for our customer would be 11. That's basically all the weighted scoring is doing. It's allowing you to have a large number of variables, more than just 2 here, and to automatically create that score for each customer or each entity that you're dealing with. Now let's have a look at the code that you use with the predictive analysis library to actually make that happen. So first we should look at the data we're going to work with. Now we've got a customer table that we've seen in some of the other examples. And if we look, we can see that we've got about 200,000 customers. We've got various bits of information on the customer. And the one I'm going to use in this example is the customer's age. And you can see we actually have a lookup table where we have a value for age, and that is actually an ID that refers to a separate dimension table. What we've also got is a fact table, which has got the actual sales transactions for every customer. So within that, we can see based on every item that was purchased, we can add up the total spend the customer has done. So for our weighted scoring, we're going to use the customer's age and we're going to use the total spend. If we just check the age dimension table here, we'll see how that's a simple join based on the ID, and we've got some already grouped or basically already binned ages. So that gives us a discrete variable we're going to use, and of course the total spend coming from the fact table will be a continuous numeric value. So in the PAL, how does that work? Well, it's very similar to what we've already seen with all the other algorithms. The name of the algorithm we're going to use is called weighted table. Of course, the manual, the PAL reference guide will give you much more information on it should you need that. We've got 5 different tables and table types we need to create to work with a weighted score table. First one, as always, is our input data. So in this case, we're going to have an ID, the ID of the customer. We're going to have the customer's age group, which is that 20 to 29, 30 to 39, and also the spend value. And in fact, you can just see below here, here's some code that I used. I created a little view based on this select statement to actually define this from the data we just saw. So we actually look at the customer table, we join the customer age's name, the description, 20 to 29, with a simple join. We actually summarize all of the sales for each customer to give us the spend value. We join that in as well. So at the end of the day, we have 3 columns. We have the customer's ID, we have their age group, and we have the actual spend amount. So going back up to the first definitions, we've got the data. The next thing we would want to be able to do is define the weighting values for each of the different variables we've got. And there are actually a couple of tables we need to specify to do this. One I'm going to call map vars for the variables, and one map values, where we actually set up a weighting for each value of the variables. And you'll see that we've got in these tables some very specific columns. I'll go to that in a minute. Let's just go and look at the code below that I've used to populate these tables. Now what we can see is in the first table here, the vars table, I've populated 3 columns, and those 3 columns represent firstly the weighting for that variable. So the first row represents our first variable, which is age. The second row represents our second variable, which is spend. So we've said 1.5 weighting for age and a 3.0 weighting for spend. I've also specified in the second column whether or not the column is discrete. So as we already have the ages grouped, I've said 1, meaning yes, this is discrete. Whereas for the spend value, this is a continuous numeric variable, so I've used 0 to specify no, this is not discrete. And the third column, we'll see in a moment, refers to the number of actual values we're going to set a weighting for. So 5 values for age and 7 values for spend. Now if we go to the other table, this is where we map the actual weightings onto individual values of those variables. Now it looks a bit complex, and basically this table has 2 pairs of columns. There is a pair of columns for each variable we're going to work with. So we have a pair for age and a pair for spend. So the first pair is age, because that's the order that we define them in. So we've got actually a row for every value, and because we need some more rows later, we put null in when there's nothing relevant with a value of 0. We've got for every one of the 5 different discrete values for age, we've put in a weighting. So in this case, younger is more important. I've given a higher weighting to younger as against older customers. And for the spend, I've done the inverse. I'm actually looking for younger customers that spend a lot. So the values we've got, each customer can spend a different value, but I've grouped this numeric continuous data effectively into something more discrete by using these groupings. So I've gone up to 1,000, 1,000 to 5,000, 10,000, 50,000, 100,000, all the way up to 300,000 and beyond. And I've given increasing weights, so an increasing multiplier or importance the bigger the salary is. Now, it is a bit strange because we're actually doing multiple variables all in one single mapping table, and that's why, for example, we have 2 sets of null values, because we only have 5 values for age, whereas we have 7 different values for spend. So that's just the structure of the table, and it does help if when you're populating that, for example, to put the columns in this way to make it easier to understand. If you were to have additional, maybe 3, 4, 5, maybe gender, male, female, etc., then you would have maybe an additional pair of columns here. You would have additional row in the variables table. So that's all defined. What you put where here is basically defined by how you've set up your input data. Again, here having age followed by spend. And so we've named the columns in a specific way. For example, for the variables, we've given weight as the first. That needs to be a double. We've got the is it discrete or not as a flag for being integer, and we've got the actual number of rows of weightings in that values table. That's again an integer. And then for the actual values table, we've got the age, that's the value of age, and then the age value, it sounds confusing, but the age value there is the weighting value, and that's a double, needs to be double. We've got spend, the value of spend, and then the value of spend in terms of its weight, again as a double. So that's how it's defined. Don't get confused in thinking that there's some relationship between age and spend. In this definition, there is no relationship between the two. It's simply one row for each value that we want to assign a weight to, and we list the columns in order. But this is 1000, it's not 1020, it's simply 1000. This is 40 to 49, has a value of 3, totally independent from what we've said at the side for the spend. So hopefully that's clear. Now we've defined that, we've got the parameter table that we've seen many times. For that, we only have one real value. It's the number of threads that we're going to use that you've already seen before. And finally, we need a results table to put the actual scores into. So here we just need an ID, which would match effectively the ID from our input data. And then we create a double column, which we've called score, which actually contains that numeric value, the overall score for that customer. So we run that using the weighted table. We would create our view. We would then create empty tables for the values and the variables, the parameters, results, put our thread number in for the parameters. And then here I've put this time into runtime the values that we're actually going to use to mapping, so that if we wanted we could tweak and change those and maybe run again. That's something you might want to do when embedding into an application. So after that, we simply just need to call the procedure and it will populate our results table, and if we want we can then have a look at the information we've specified. And in this case I've actually created a little view to make it easier, so we can see our score actually joined on with all the variables from our source data as well. So let's run that code. Let's run it all in one quick go. Again, we're working with actually 1 million transactions with 200,000 different customers, yet we've now got in just a couple of seconds in memory with HANA, 1.3 seconds it took to actually do that scoring process. So you can see here, this is actually our final result. We've got the ID of the customers, we've got their age group, we've got their spend amount, and actually the scoring. And I've just taken a top 100 descending by score, so these are the best scores, the highest scores that we have in our results. And what we can also see if we want to is we can have a look at the input data. This is just showing the table where we've put in the values of spends and the weightings that are associated. We can see the same for the weightings for each individual variable, so one row per variable in that same order. So we see it runs. It's very straightforward, very easy to do. What we might want to do, for example, is maybe change the weighting a little. Maybe we increase the importance of maybe having a very low salary, or we can do anything we want. Maybe we increase those that are above 300,000. We maybe give them an even higher rating, so we put them up to 9, and maybe the ones that are in their 30s, we'll give them equal importance with people that are in their 20s. Maybe that's more relevant. So we can just refresh these tables, clear out the results table, and run the algorithm. Again, it takes just actually less than a second to run that, and then we can start to look at our results. And again, in this case I just happen to have looked at the top 100 with the best scores. So you can see here are the best scores, and you can see these are the customers in there, and they're belonging to the 20 to 29 age group. So that's how we perform credit scoring using the weighted scoring table approach. That's something available in the HANA Predictive Analysis library, and good luck with using that.